Okay, so just a quick video on common types of behavior associated with the non-existence of limits. And this is the very beginning of calculus, and we're starting to really talk about limits, and we know that a limit has to be a specific height, a k value, a real number, and sometimes it doesn't work out that way. So here are three ways in which it's most likely that those things don't occur. One, in red here, as f of x approaches a different number from the right side than it does from the left side. That is, it's moving towards a height. As you move from the right towards the left, you're approaching one height, but if you're moving from the left towards the right, towards the same x value, you're approaching a different height value, and I'm going to show you a good example of that in a second. Second is when f of x increases or decreases without bound as you approach that x value of 7 or 3 or 2 or 0 is the one we're going to use a lot today. So that's the second way. And then lastly, that f of x oscillate. It changes quickly between two heights, and there's these two fixed heights as x approaches c. And we'll see what that looks like in just a second also. What I'm hoping that you're going to do right now is you're going to stop the video, take these notes, turn the video back on, and then support the notes that you've just taken with these examples. So here's the first example, and this is of f of x approaching different heights from either side. So what I did was on the CAS I put in this function f of x, and f of x is equal to the absolute value of x over x, and you can just numerically see what that would do if you started to approach 0. We know that x can never go to 0, right? X can't go to 0. So we have a domain issue there. So I'm interested in what's going to happen there. So I look here and I'm like, there's this domain issue here. X can't equal 0. So we know that. We say x cannot equal 0. So now what I want to know is, well, what happens when I get really close to that number verboten? So let's say this, and I'm going to look at that and say, well, what is the limit of f of x? Does it exist as x approaches 0? So what I'm going to do is I'm going to do this graphically, and I'm just going to start from the right-hand side. I'm just going to move to the left. And when some people are going to start out at like 1,000, but no, I actually want to start at some number near the number I'm interested in. So I'm here, and this looks like really good behavior. I'm like, this is working out perfectly for me, right? If I'm unaware of what's happening on this side, this looks really good. I know, but so I get here. So part of that limit process is, part of the process of finding a limit is to look from both sides. So I start to look from here. I'm like, well, this is weird, because now I seem to be approaching a height of -1, and then I get closer and closer, and it doesn't change. So here, as I approach from this side, it seems like I'm approaching a height of -1. As I approach from this side, I'm approaching a height of 1. I'm approaching two different heights as I get arbitrarily closer to the number I'm interested in, and therefore the limit fails to exist. Okay? All right, so here's the second example. Here's the second example, and that second example is of unbounded behavior. And it looks like that. Nope, it looks like that. There you go. Looks like this. And all I did here is I put into my calculator f of x is 1 over x squared. And it's just one of the many functions I could use, but this is the one I chose today. And then I just start looking at the limit graphically. And as I do, I start to realize that there's a problem. Again, I looked here, and I realized, look, x cannot equal 0, right? That's a domain issue. So that brings the question to me. I say, okay, well, what's the limit? What happens as I get arbitrarily close to 0? So what is the limit of f of x as x approaches 0? Do the same thing. I'm graphically starting from the right-hand side and moving left. And I'm like, you know what? This is pretty smooth. This is okay here. And then all of a sudden, as I get really close to 0, just little tiny movement in x, as I just move a little bit closer to 0, I get this enormous change of height, right? So little tiny changes of x give me enormous changes in height. So I'm like, you know what, let me check it from this side. I check from this side, and lo and behold, same thing. As I get really close to x is 0, the height goes nuts on me, doesn't it? And it starts to approach positive infinity. And the problem with that is that this is not a real number, right? So here, the limit fails to exist. Okay, last example. I think this is working out good, hopefully. And hopefully you're stopping the video and taking some quick notes. Save you a lot of time in lecture, I think. So here's that last example. We talked about that oscillating behavior. Again, we look here and we realize there's a problem at x equals 0. So that's what I want to know. Now I want to know, well, whoa, that's what whoa, sorry about that. That's what I want to know. I want to know, well, what happens? And what happens is this. As I get really close to 0, the height oscillates. Look right here, it's -1. Just a little tiny movement in x towards 0, and I'm at +1. Little tiny x movement, and I'm back down at -1, and then back up to +1. And if I do it from this side, same thing. As I get closer, I'm like, oh, the limit is 1. No, the limit is -1, and it just keeps going back and forth, back and forth, back and forth. And this oscillating behavior precludes us from being able to take a limit here. All right? So those are the 3 examples that we have of how this works. So what I'd like you to do really is just go back and just fix your notes up. Let me just give you this one more time. Of course, you could just go back to the video, but here are those notes. So hopefully go back here and put in, graphically draw in, well, what evidence is it? What kind of equation would support this lack of a limit here? And what kind of equation and what kind of equation here? To have it said you're not going to be asked questions, especially on the free response. And in the multiple choice, you're going to be asked some of these questions, and you should just ace them. But it would really help a ton to know why and under what conditions the limit fails to exist. All right, you guys, good work.